just for this simple system. Now, this is our series. Exponential t is that everybody knows equal to 1 plus t squared divided by 2, and then t cubed is the power 3, and divided by 3 factor like this. Okay. Anybody can tell me why exponential t is written in this way? Does anybody know how this called exponential t? Why the exponential t is written in terms of a power series? Anybody knows the reason about it? Everybody knows exponential, right? Why we have these exponential functions? Why we have sine function? Why we have cosine function? Why? Everybody know? Everybody know what's going on about this? I think you learn a lot of math, right? But why we have these exponential functions? As a matter of fact, the sine function, exponential function, cosine function, tangent function is not really a exact solutions. So this exponential function equal to that series expansions. Now, where they come from? Why? Anybody knows? No? Okay. This is, now today we know this is, we call t, that's exponential function. Then we also have sine function. And we also cosine function. And you learn anything, any known, like Bessel function, you heard about Bessel function, right? You have heard about a lot like Legendre functions, a lot of different functions in mathematics. All right. Now, how we solve the equation of motion? Let us look at the second view. This is the exponential function. All right. If you look at, if we choose only 0 term, that's it, that's all one. You choose 2 terms, you choose 3 terms, you choose 7 terms, you choose 8 terms, then it's close to the this exponential function. Now, let me ask you, how many terms your computer use to solve this exponential functions? Do you know? Anybody knows? Huh? 30, 40, 60, 100? Nobody know, right? So how many terms are necessary? Or how many terms are sufficient to do this? No? How many? Like at your computer, how many? So, I tell you what, this exponential function is an approximate solution. There's no exact solution for exponential functions. The same thing, the sine function, there's no exact solution for sine functions. You can write this, some mathematicians, they want to say, okay, I have 1,000 terms, I have 2,000 terms, mine is better than yours. From engineering point of view, we don't need that many terms because our computer accuracy may be up to only 10 digits. Beyond that, it doesn't do any good. Right? So, now why we have these kind of exponential functions being invented? I call invented these exponential functions. This is because no matter what kind of differential equation you try to solve, initially, all the differential equations being solved in terms of the power series. That's the reason. Okay, now let us look at this. The exponential functions ex can also be expressed as the function of y, and this is the t equal to log called y. The same reason log y is also an approximate solutions. So today we are solving all differential equations only in terms of approximate solutions. Okay, this is just a mess. It's also the limit. That's so. This is three different expressions for exponential function. This is the three ways you can do it. If you look at this exponential t equal to limit k going to infinity, parenthesis 1 plus t over k and parenthesis k. K has to go to infinity. But there's no any computer can let you have a term go to infinity terms. Right? So you gotta understand that doesn't matter what you're doing, your differential equations, the solution of the differential equation is only an approximate solutions. So that's the message I'm trying to tell you. For the convenience, mathematicians call this kind of series called ET. E subscript T. Why don't they call AT? Why not call BT? Why we call ET? Well, this happened to be not mathematicians. He defined it. So he defined using E, then we are using E. Okay? Understand that? Understand now? So this, the reason why I give you this exponential t, later on I will show you if t is not scalar. Now et, now this t is a scalar. This is a scalar. If t is a matrix, how can you solve it? T can be a matrix too. T doesn't have to be a scalar. So a mathematician will come in to tell you, okay, I can define a power series for a matrix. Potential of a matrix. All right, homogeneous solutions. All right, we have called the y equal to exponential gamma t. Let y equal to exponential gamma t, and then we sub in here. Then we'll find out there's a characteristics equations. A0 gamma n plus A1 gamma n minus 1 plus, and so on, A n minus 1 gamma plus A n equal to 0. All right. Now the question is, why we assume y equal to AE gamma t? Can we have any other assumption for that? Do you know, anybody knows why, when you solve the differential equation like this, why we are using the y equal to e gamma t? Anybody can tell me why? I know your teacher taught you that. Your mathematics teacher taught you that. Right? Agree? Anybody can tell me? Why? Any reason? When your teacher taught you that this is the solutions, so you believe him or believe her, right? And so you gotta believe me. See? So when you learn the math, you need to ask questions. So next time when you have children, you're then going to school, and then you tell your children, go to school, ask your mathematics teacher, say why this is true. All right? I tell you what, there's a reason. Because the mathematicians don't know how to solve this problem.